Welcome students. Sparkle Mind சேனலுக்கு உங்களை வரவேற்கிறேன். இந்த வீடியோவில் ப்ராப்பர்ட்டிஸ் ஆஃப் டெஃபினைட் இன்டெக்ரல்ஸ் தொடர்பான முக்கியமான கொஸ்டின்ஸ்களுக்கு ஆன்சர்ஸ் பார்க்கலாம். We will see the solutions of properties of definite integrals. இந்த வீடியோ லைக் பண்ணுங்க, ஷேர் பண்ணுங்க உங்கள் ஃப்ரெண்ட்ஸுக்கு. இது ரொம்ப யூஸ்ஃபுல்லாக இருக்கும். ஓகே, வீடியோக்குள்ளே போகலாமா? Question number 1. Limit 0 to pi by 2 sin theta d theta by 25 plus cos theta into 26 plus cos theta. Solutions. Take 25 plus cos theta is equal to t, then dt is equal to minus sin theta d theta. If you take substitution, we have to change the limits also. When theta is equal to 0, then t becomes 25 plus cos 0, that is cos 0 is equal to 1, then it becomes 26. Similarly, when theta is equal to pi by 2, then 25 plus cos 90, that is cos 90 is equal to 0, we know that 25 plus 0 is equal to 25. Therefore, limit change to 26 to 25. Then, we substitute the value of minus sin theta d theta is equal to minus dt by t into t plus 1. Therefore, it becomes t plus 1. Then, this is a factors, so we use the partial fraction. Then, minus 1 by d into t plus 1 is equal to a by t plus b by t plus 1. Taking LCM on both sides, t a into t plus 1 plus bt is equal to minus 1. Then we get the values a and b. Substitute t is equal to 0. We get a is equal to minus 1. If we put t is equal to minus 1, we get b is equal to 1. Therefore, minus 1 t into t plus 1 dt becomes minus 1 integral 1 by t dt plus 1 integral dt plus t plus 1. Limit 26 to 25. 1 by t dt is equal to minus log t. Here minus is there, therefore it becomes minus log t, and this becomes log t plus 1. Then log t plus 1 by t, limits upper limit minus lower limit. First upper limit minus lower limit. T is equal to 26 by 25 minus log 27 by 26. Here log minus nala, log 26 by 25, it becomes reverse 26 by 27. We get log 26 square by 25 into 27. Then we get log 676 by 675. Therefore, value of sin theta by d theta by 25 plus cos theta into 26 plus cos theta becomes log 676 by 675. Question number 2. Using the properties of definite integrals, prove the following. 0 to pi h sin x dx is equivalent to 2 into 0 to pi by 2 h sin x dx, where h sin x is a function of sin x. Show the property used. Here the property is, if f of 2a minus x is f of x, then 0 to 2a f of x dx is equal to 2 into 0 to a f of x dx. So 2a வந்து 2 into a னு we can split பண்ணிக்கலாம். 2 into 0 to a f of x dx. Here 2a is equal to pi. Then a is equal to pi by 2. So f of x h sin x by f of 2a minus x, that is h into sin pi minus x. Here h sin x. So pi minus x. Pi means 180 minus theta sin 180 minus theta sin theta sin x. It lies in the second quadrant only. Therefore, since second quadrant sin has plus positive value, therefore h sin pi minus x becomes h sin x, that is f of x. Therefore, 0 to pi h sin x dx is equal to 2 into 0 to pi by 2 h sin x dx. Question number 3. The value of minus pi by 2 to pi by 2 x cube sin power 4x dx. Here f of x is equal to x cube sin power 4x. Then f of minus x we get minus x cube plus sin power 4x, that is minus f of x. If f of x is equal to minus f of x, then f of x is a odd function. F of x is a odd function. If f of x is odd function, then minus pi by 2 to pi by 2 x cube sin power 4x is equal to 0. Next one, evaluate 0 to pi x tan x by secant x plus tan x dx. Solution. Here take I is equal to 0 to pi x tan x plus secant x plus tan x dx. Using the property 0 to a f of x dx is equal to 0 to a f of a minus x dx. Here a is equal to pi. Therefore 0 to pi x வந்து pi minus x. Here tan pi minus x plus secant pi minus x and tan pi minus x. Tan pi minus x. Tan 180 minus theta no change. But quadrant is tan theta is pi minus and x is the second quadrant. Here tan minus. Like that secant also in second quadrant minus. Therefore 0 to pi minus x minus tan x minus secant x minus tan x. Taking common minus in denominator and remove cancelling, we get 0 to pi minus x tan x by secant x plus tan x. Then we have split into two parts. 0 to pi tan x by secant x plus tan x minus x tan x by secant x plus tan x. Then taking separate limit 0 to pi tan x by secant x plus tan x minus 0 to pi x tan x by secant x plus tan x. Here this one is I. Therefore I is equal to 0 to pi tan x secant x minus tan x minus I. I means it is the given sum integrate part. Here I is equal to 0 to pi x tan x by secant x plus tan x. Therefore 2i is equal to 0 to pi, pi tan x plus secant x plus tan x. Here we had converted into sin by cos. Tan is equal to, we know that sin by cos, secant is equal to 1 by cos, tan is equal to sin by cos. Taking LCM and rearranging, we get this sum becomes 2i is equal to pi into 0 to pi sin x plus sin x by 1 plus sin x. Then rationalize the denominator, we get sin x by 1 plus sin x into 1 minus sin x by 1 minus sin x. That is multiplying numerator and denominator by 1 minus sin x by 1 minus sin x. In the denominator we get here a plus b into a minus b form. Therefore, is equal to we get a square minus b square. Here a is equal to 1, b is equal to sin x. Therefore, denominator becomes 1 minus sin square. Here 1 minus sin square is equal to cos square x, we know that. Then numerator is sin x minus sin square x by cos square x. Then taking separately sin x by cos square x minus sin square by cos square x. Here sin x by cos x into 1 by cos x. Here sin by cos is equal to tan, 1 by cos is equal to secant x. Therefore, it becomes secant x tan x minus tan square x dx. Then 0 to pi integral secant x tan x minus tan square x dx. Tan square x is equal to, we know that 1 plus tan square is equal to secant square x. Therefore, tan square x becomes secant square x minus 1 dx. So, integral secant x tan x dx is equal to secant x, and integral secant square x tan x, integral 1 dx is equal to x. So, on simplifying we get pi into secant x minus tan x plus 1, limit 0 to pi. Applying the limit, upper limit pi, secant pi minus tan pi plus pi minus lower limit 0, secant 0 minus tan 0, 0, we know that x is 0, 0. Secant pi is 180, secant 180 is equal to secant 0, secant 0 is equal to 1, but 180 becomes second quadrant, therefore secant pi is equal to minus 1. Tan 0 is equal to 0, pi minus 1. So, we get pi into pi minus 2, 2i is equal to pi into pi minus 2, I is equal to pi by 2, pi minus 2. Fifth one. Integral minus 1 to 1 log 2 minus x by 2 plus x dx. Here we see here one thing. Integral minus a to a f of x dx form. So first we have to check up if f of x is equivalent to minus f of x, then it is an odd function. Then it becomes 0. If it is even function, that is f of x is equal to f of s, we have to solve using the integral. So first we have to check up if whether it is odd function or even function. Here f of x is equal to log 2 minus x 2 plus x, f of minus x. So we have to substitute, we get log 2 plus x minus 2 minus x. If we take minus common here, it becomes minus f of x. This is minus f of x. Therefore, f of x becomes minus f of x. F of x is odd function. Then we get the value 0. Sixth one. Evaluate 0 to pi by 4 log 1 plus tan x dx. Solution. Let I is equal to 0 to pi by 4 log 1 plus tan x dx. In this case, we have to use the property f of x is equal to f of a minus x. That is, replace f of x, f of pi by 4 minus x. Here, a is equal to pi by 4. Therefore, 0 to pi by 4 log 1 plus tan pi by 4 minus x. Here, tan pi by 4 minus x, that is tan of a minus b. Tan a minus b is equal to, we know that tan a minus tan b by 1 plus tan a tan b. Like that, a here pi by 4, b here x. Then, we know that tan pi by 4 is equal to 1. So, using this value, we get log 1 plus tan pi by 4 minus tan x plus 1 plus tan pi by 4 tan x. And using the value of tan pi by 4 equal to 1, we get log 1 plus 1 minus tan x by 1 plus tan x. And taking LCM, we get 1 plus tan x log 2 by 1 plus tan x. So, this becomes log 2 minus log 1 plus tan x dx. Here 0 to pi by log 2 dx minus, this is the integral part. So, put I here. So, adding, we get 2i is equal to log 2 0 to pi by 4 dx. Integral dx is equal to x. 0 to pi by 4 using the limit, we get 1 by 2 into pi by 4 log 2. That is, I is equal to pi by 8 log 2. Seventh one. Evaluate log root 2 to log root 3, 1 by e power x plus e power minus x into e power x minus e power minus x dx. Solution. E power minus x is equal to 1 by e power x. We know that. Then this is in the form a plus b into a minus b. That is e power x plus e power 1 by e power x into e power x minus 1 by e power x. Therefore, this one a plus b into a minus c, know that a square minus b square. Here a is equal to e power x, b is equal to 1 by e power x. Therefore, this becomes 1 by e power 2x minus 1 by e power 2x dx. Then taking LCM for the denominator becomes e power 4x minus 1 by e power 4x e power 2x. Then it becomes e power 2x by e power 4x minus 1 dx. Then take e power 2x is equal to t. Then dt by dx is equal to 2 e power 2x. Then dt is equal to two x dx. Then we have to change the limit also. When x is equal to log root 2, then t becomes 2. We know that e log x is equal to x. Use this formula. E log x is equal to x. Like that, e power log 2 becomes 2. Similarly, when x is equal to log root 3, t becomes 3. So, limit change from 2 to 3. So, rewrite the equations like that. Limit 2 to 3, 1 by 2 dt by t square minus 1. That is half into 2 to 3 dt by t square minus 1. This is in the form integral dx by x square minus a square is equal to 1 by 2a log x minus a by x plus a. Here x is equal to t, a is equal to 1. Substituting the values, we get 1 by 2 half log t minus 1 by t plus 1. Using the limits upper limit 3 and lower limit 2, we get the value of 1 by 4 log 3 by 2. One by 4 log 3 by 2. Eighth question. Here minus 1 to 2 absolute value of x cube minus x dx. Here they are given absolute value. So absolute value we have to take positive and negative values for both this one. So if you take x cube minus x is equal to 0, then we get x square minus 1 into x is equal to 0. So we get x is equal to 0 and x square minus 1 is equal to 0. That is x is equal to plus or minus 1. Therefore, limits minus 1 to 0, 0 to 1 and 1 to 2. Here minus 1 to 0. So if you put minus 1 to 0, x is equal to minus 0.5, we get positive. Therefore minus 1 to 0, it is positive value now x cube minus x plus. Then if we take x is equal to 0.1, then we get negative. Therefore, in the interval 0 to minus 1, it has negative. So, decreasing. Therefore, minus of x cube minus x dx. In the interval 1 to 2, if we take 2 or 2 now, we get positive. Therefore, in the interval 1 by 2, the function is increasing. Therefore, minus 1 to 2 absolute value of x cube minus x dx becomes minus 1 to 0 x cube minus x plus 0 to minus 1 negative of x cube minus x plus 1 to 2 x cube minus x dx. And x cube minus x cube derivative integration of x cube is equal to x power 4 by 4, x is equal to x square by 2. Then using the limits minus 1 to 0, 0 to 1 and 1 to 2, we get 11/4. Here upper limit x is equal to 0, but lower limit minus of minus 1 we have to use here. So answer is 11/4. Here also, next question 9. -1 to 1, absolute value of x power 4 minus x dx. So x power 4 minus x lies in the interval x is equal to 0 or x is equal to -1 or x is equal to +1. If we put x is equal to minus 0.1, we get here positive, here also positive. So x power minus x is greater than or equal to -1 to 0. Then if we put 0.5 here, 0 to 1, take any point, 0.5, x is equal to 0.5, then x power 4 is equal to 0.5 power 4 minus 0.5. So it becomes 0.625 minus 0.5. So we get 0.5 is minus 0.5 is greater, though we get negative. So in the interval 0 to 1, it is decreasing. Understand the key point. -1 to 0, x power 4 minus x is increasing, whereas in the interval 0 to 1, it is decreasing. Therefore, -1 to 0, we take positive value x power 4 minus x dx, plus 0 to 1, we have take negative of x power 4 minus x dx. X power 4, see n plus 1 by n plus 1. Therefore, x power 5 by 5 minus x square by 2. Then using the limit, here -1 to 0, here 0 to +1. We get the answer 3/5. Question number 10. Find the value of 1 to 4, absolute value of x minus 1 plus absolute value of x minus 2, absolute value of x minus 3 dx. Here we have 3 parts. So in each part, we have to check. Here first one, 1 to 4 modulus of x minus 1 dx. If we take x is equal to 1.1, we get 0.2 is greater than 0. Therefore, here 1 to 4, it is increasing. Therefore, x square by 2 minus x, using the upper limit, we get 9/2. Then second part, x minus 2. Here x minus 2, x is equal to 2. So x is equal to 1. If we put x is equal to 2. If we put x is equal to 1, we get negative. Therefore, it is decreasing. If we put x is equal to 2.2, then we get positive. Therefore, in the interval 1 to 2, it is decreasing, and 2 to 4, it is increasing. Therefore, we get x minus 2 dx minus x square by 2 minus 2x by, then upper limit 2 by lower limit 1. Like that, x square by 2 minus 2x. Here upper limit 4 to 2. So substituting value of 2 and 1, we get half in this part. Here substituting 4 and 2, we get 2. Half plus 2, 5 by 2, second part answer. Third one, here absolute value of x minus 3 dx. So x is equal to 3. If we put x is equal to 2, we get negative, therefore it is less than 2. If we put x is equal to 3.5 or 3.1 anything, then we get 3.1 minus 3, we get 0.1 is greater than 0. Therefore, in the interval 3 to 4, it is increasing function. Therefore, in the interval 1 to 3, it is decreasing. In the interval 3 to 4, it is increasing. Then we get, on solving, we get x squared by 2 minus 3x, and using 3 to 1 limits, we get plus 2. And second part, x squared by 2 minus 3x, using the limits 4 and 3. Here 5 minus 9 by 2. On solving, we get 5 by 2. Here first part we get 9 by 2. Second part we get 5 by 2. Third part we get 5 by 2. So adding, we get 19 by 2. Next one, 11th. 0 to 1, x 1 minus x n dx. Solution, take integral part is equal to I is equal to 0 to 1, x 1 minus x power n dx. Here we have to substitute f of x is equal to f of a minus x. We have to use the property. Here x is a is equal to 1. Therefore f of 1 minus x. So 0 to 1, x becomes 1 minus x. 1 minus x becomes here x power n. So multiplying, we get xn minus xn plus 1 dx. On integrating, xn plus 1 by n plus 1 minus xn plus 2 by n plus 2, limit 0 to 1. Applying the limit, we get 1 by n plus 1 into